When we talk about powering our cities with renewable energy, we almost always look up. We build solar arrays to catch the sun and turbines to capture the wind. But down at street level, nearly every major coastal city produces two constant flowing resources that run 24 hours a day: millions of gallons of ocean water and municipal sewage. For over a century, urban planners have kept these two water streams strictly separated. They only meet at the very end of the line, when treated wastewater is discharged directly into the sea. Treating that intersection strictly as a disposal point leaves a predictable energy source untapped. Every gallon discharged into the bay represents a measurable volume of kinetic energy allowed to dissipate into the tide. In Fukuoka, Japan, the urban infrastructure pushes right up against the ocean. It is a dense metropolis where these water sources are in constant proximity. Engineers here are now intercepting the disposal process. Instead of simply dumping the water, they are routing it to a facility designed to bring saltwater and treated sewage together. This facility is Asia's first and the world's second osmotic power plant. It is designed to extract electricity directly from the convergence of these two distinct water types. The process relies on a specific chemical interaction. It requires generating a reliable electrical current using only seawater and the liquid byproduct of the city's sewage system. The process starts at an industrial scale. This filtration plant processes millions of gallons of urban waste into treated sewage, which has the chemical properties of freshwater. When that salty seawater finally collides with the purified sewage water, an intense physical reaction occurs. Because of the differing salinities, physics demands an immediate chemical equilibrium between the two liquids. The freshwater aggressively tries to dilute the saltwater. This natural drive to balance the salt concentration creates a measurable physical force. This chemical drive for balance results in genuine kinetic energy. It is a pressurized, natural force that can be harnessed by the right mechanical system. Scientists call this specific force osmotic pressure. This diagram shows the capture process. A semi-permeable membrane sits between the two streams. Freshwater particles push through into the saltwater side. Trapped salt particles cause the saltwater volume and physical pressure to rapidly increase. This high-pressure liquid spins a turbine to generate electricity. The system requires no fuel combustion. The plant effectively extracts kinetic energy from a chemical reaction that the waters were already destined to perform. This facility generates approximately 880,000 kilowatt-hours of electricity every year. While a small fraction of the city's total grid, it provides enough power to sustain roughly 200 Japanese households using only existing waste streams. This marks the first time this technology has been deployed at an industrial scale in Asia, and only the second time anywhere in the world. This milestone moves osmotic power from theoretical physics into a functional utility, demonstrating that any coastal city with a treatment plant can potentially contribute to its own power supply.